This video is going to cover finding the area of a parallelogram. And a parallelogram, remember, is where opposite sides are parallel. First, let's define altitude. Altitude is a perpendicular line segment that measures the height of a geometric figure. So here I have three types of geometric figures. I have triangle, parallelogram, and a rectangle. So over here I have two triangles. We have a right triangle and an acute triangle. If you notice, the altitude is a segment that's drawn perpendicular. Over here for this acute triangle, the altitude is perpendicular line segment. They are drawn from a vertex to the perpendicular to the opposite side, from a vertex perpendicular to the opposite side. Here's a parallelogram. The altitude, again, measures the, it's a perpendicular line segment drawn from a vertex to the opposite side. And our rectangle, the altitude would be a perpendicular line segment drawn from a vertex to the opposite side. And if you notice, if you think about all of these geometric figures sitting on a table, where the table's right here, these altitudes represent how high each of these figures stands, from the table, how high it stands, from the table, how high it stands. So you can tell that these altitudes represent of the height of those figures. So remember, for the triangle, the altitude of a triangle is the perpendicular distance from a vertex to the opposite side. And we also said for the triangle that an altitude could lie inside, on, or outside of the triangle. So similarly for parallelograms, right, we're going to have an altitude drawn from one of the vertices to the base, okay? So to find base of a parallelogram, it could be any of its four sides, okay? The altitude of a parallelogram rises perpendicular from the base to the opposite side. It's a perpendicular segment, and the height of a parallelogram is the length of its altitude. So in this first one, the base is the bottom side. So if we draw a line perpendicular from that base to the opposite side, that represents the altitude or the height of this parallelogram. If we picked the side on the left here to be the base, then we would have to draw a perpendicular segment from that base, right, perpendicular to its opposite side. In this case, it would be outside, so we would extend this side, okay? It would be the altitude or the height of the parallelogram. Normally we figure height, we always think of the base as something on the bottom, but it really doesn't matter. I could turn this figure and place this, horizontally on the table. And then this one, if I pick the top side to be the base, then I would have to draw a perpendicular segment rising to the opposite side. So the area of a parallelogram is going to be base times height, base times height, base times height, where the height is the altitude. And the altitude is a perpendicular line segment drawn, right, for a geometric figure to represent its height. So area of a parallelogram, base times height. Well, the area of a parallelogram really is technically the same as the area of a rectangle. So the rectangle, we had area equals length times width, and now we have parallelogram, area equals base times height. But we can change the length and width in this rectangular area formula to base and height for rectangles and squares. Why? Because remember, rectangles, right, have four right angles. Therefore, if I picked this side down here as the base, right, then it's the other, and that would be the width in this case, right, because it's the shorter length side. Then the longer side here would be, which was our length, now becomes the height, because it's drawn perpendicular to the base. If I looked at it this way and I said, okay, well, this used to be the length here and the width, but if I called this the base, well, then the height is going to be drawn from that base perpendicular to the opposite side. So we can interchange the length and width to base and height, and the formula would work for both rectangles and parallelograms. So take a look at this quick video and see how we can change these parallelograms into rectangles and squares. But before we do, look at the altitudes for these parallelograms. Can you see how they form right triangles? So take a look here. The top one is like our blue rhombus. Remember that little right triangle that we saw there on the left? Watch what happens if I take that right triangle and move it over to the right-hand side. I now have a square. Same thing with the parallelogram down there. If I take that right triangle from the left and cut it out and move it to the right, I now have a square and a rectangle. And so here's just another picture of that showing how we move this, cut out this right triangle here and move it to the other side here. I change that rhombus to a square. If I take that right triangle, cut it off, move it to the other side, connect it to this vertex here, I change it into a rectangle. That's just to demonstrate that the area equals base times height will work with both squares, rectangles, and parallelograms. So let's find the area of this parallelogram. Well, first we take a look at the area formula, which says base times height. So you have to identify the base and height. So that's the first step. All right, so our base is going to be determined by the altitude, okay, because it has to be perpendicular to the base. So we're going to look for a perpendicular segment, and I see this perpendicular segment right here. So that is my height or my altitude. Okay, and the altitude has to be drawn, right, perpendicular to the base. And so that is perpendicular to this side, the bottom side right here. So that determines the base. So the base is 25 inches, and the altitude is the height, so the height is 14.4 inches. And then we just plug them into the formula, right? Base 25 times height 14.4. Put that into our calculator, and that equals, oops, sorry with my little clicker, equals 360 inches squared. Remember, area is always measured in square units, and for in here I should put 25 inches, 14.4 inches. So 25 times 14.4 is 360, and inches times inches is inches squared. And so the area of our parallelogram is 360 inches squared. Okay, and so when you identify the base and the height, you're going to look for that perpendicular segment. Okay, the perpendicular segment that's not one of its sides, right? Because it's going to be perpendicular to one of its sides. Well, the side it's perpendicular to is the base, and the altitude is the height. So hopefully this explains, describes to you how to find the area of a parallelogram.